flash, people die, and the living suffer catastrophic injuries. Home and abroad, bombs are the weapons of choice for terrorists.
What size and kind of explosive is that?
That's C4, equivalent to 2 pounds of TNT.
For security reasons, we can't tell you the location of this test range. Here, explosive experts think like terrorists.
The trash cans in airports and railway stations are absolutely the first place that a bomb's going to start, because it's so easy just to drop something in and walk away.
Executives with Clearwater-based Blast Guard International set up to test what they believe will save lives. It's called Blast Wrap.
With this, you're turning the force of a stick of dynamite into something like a firecracker?
Basically, yes.
Flexible plastic pockets filled with a combination of volcanic ash, salts, and other materials.
We suffocate the fireball, reduce the blast pressures, and when you do that, if you reduce the blast pressure, that means that fragments from those explosive devices are going to be diminished greatly.
All clear down range. Fire in hole.
2 pounds of C4 explosive blows apart this metal trash can, the type widely used around the country.
The ring from the trash can ended up way down there in the woods, maybe 200 feet or so. It flew a long way after the explosion.
It was a disaster, in my opinion. Fragments like this are potentially highly lethal.
Testers then set up a container insulated with blast wrap.
This will dramatically suppress the pressure and dramatically suppress the fireball.
12 pounds of TNT.
Fire in hole.
Sure enough, the can stays intact after exploding the equivalent of 12 pounds of TNT, enough to damage a large building. They'd also done their own testing on oil pipelines, first exploding an unprotected section, resulting in a gaping hole. A section insulated with blast wrap, stayed together, and wound up with only a dent. But what about people who would be in and around the blast site?
To anyone outside of 10 feet, the worst case scenario at 10 feet would be some minor ear damage, and at 15 feet we have reduced it to a point where no one's injured at all.
The U.S. military recently took notice and began doing their own testing with blast wrap. The Blast Guard demoed a car blown apart by explosives similar to an IED, the type of terrorist bomb that targets military convoys in Iraq. When they protected the undercarriage of another vehicle with blast wrap,
The doors open.
they reduced the bomb's impact to the point where the doors stayed on and the windows didn't shatter.
Now, our blast mitigation system reduces that blast to the level the human body can stand. It won't be a very pleasant experience, but you walk away alive.
Blast wrap, they say, can take on any shape and can protect luggage containers on airliners, whole walls of large buildings, and power plants and utilities from terrorist bombings. An innovation with infinite possibilities to safeguard against a real threat. Lloyd Sowers, Fox 13 News.
Blast Guard International conducted feasibility tests for a radically new and improved trash receptacle in Bakersfield, California in September last year. The first of those tests had a 10-pound charge, unmitigated, of C4. This high-speed video, replayed at 2 frames per millisecond, shows the super hot, very large fireball of long duration that indicates extremely high pressures being developed in this blast. It's clear this is a very destructive large charge event. In fact, using TM5 855-1, the calculated pressure developed in this blast was 18.9 psi at 15 feet of standoff. We'll come back later to define that pressure in human injury terms. Now let's look at the same 10-pound charge, but this time with only 3 inches of blast wrap protection. In this high-speed video replay, the stark contrast between the prior unmitigated test, in which the white-hot fireball lasted in excess of 200 milliseconds, you clearly see in approximately 4 milliseconds in this event with blast wrap protection that the fireball is completely quenched. The dramatically lower pressures in this blast guard mitigated event will generate a tremendous reduction in human injury. Later in this presentation, we'll relate these pressures to human injury. To conclude this series of feasibility tests in the California desert, we shot a huge 20-pound charge of C4. In this high-speed video replay, once again, you can see the blast wrap mitigated event is quenched in only a few milliseconds. These positive results from these feasibility tests obviously prompted Blast Guard to further develop this new blast resistant and blast mitigating line of trash receptacles. The next series of tests that we'll show were for full-scale initial prototypes of our new blast resistant trash receptacle. This is a clip of the Blast Guard MTR-91 shot on December 22nd of 2004 at the U.S. Army's Redstone Technical Test Center in Huntsville, Alabama. Here you see the receptacle right before the test shot, and here you can see the medium charge of C4 touching the inner liner immediately at the interior weld seam.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, test.
Obviously, the Blast Guard MTR-91 has stayed together with no secondary fragmentation. And having no primary or secondary fragmentation is terrific performance. But intense blast pressure maims or kills. So let's take a look at the same shot in high speed. At a replay rate of 8.3 frames per millisecond, as you can see, this blast is quenched in a very short period of time. In this case, approximately 3.5 milliseconds. This instantaneous quenching represents a tremendous reduction in the fireball and the total thermal output of this event. So like other premium blast-resistant trash receptacles, this one stayed together. The difference, however, was that in the Blast Guard MTR trash receptacle, the peak pressure was dramatically reduced to not only a non-lethal, but also a non-injury level. So the bottom line is, like other blast-resistant trash receptacles, the Blast Guard MTR prevents primary fragmentation and will remain intact after a blast. However, unlike any others, the MTR provides a comprehensive and profound degree of blast effects mitigation. In this test, the peak pressures measured by the two transducers were 4.8 and 3.5 psi. Those pressures compare to a calculated peak pressure for this charge size of 26.27 psi. That means the Blast Guard MTR generated reductions of 81.7 or 86.7% in blast pressures. So here's the payoff. At the 10-foot standoff at which these pressures were measured in this shot, human injury would be extreme and near certain death would result. But in the blast mitigating Blast Guard MTR, the person would walk away injury-free. The BlastGuard MTR is available now from BlastGuard International Incorporated or a nationwide network of representatives for Centerpoint Manufacturing. These are clips from the first finished product testing of the BlastGuard MTR 101 held December 22nd of 2004 at the Redstone Technical Test Center in Huntsville, Alabama. Here's a view of the receptacle before the test shot and inside, touching the liner, positioned exactly at the weld seam. You can see the large charge.
Minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, test. 3, 4, 5.
As you can see, there was significant internal damage, including a split of the internal weld seam. However, there was only bulging on the exterior of the container, indicating clearly that there was no secondary fragmentation whatsoever. Now let's take a look at the same view in ultra-high-speed video, in which you can count about 8.3 frames per millisecond. Now as we watch this high-speed video replay, what becomes apparent very quickly is the speed at which this intense fireball is quenched and completely shut down. In fact, in something under 4 milliseconds, this event is completely over. This next split-screen clip will demonstrate very clearly the stark contrast between the blast size, intensity, and duration, both with and without blast wrap. This replay is at 50 frames per second, and the blast wrap protected is in the lower right corner. At this replay speed, you'll have to watch quickly. That unbelievable contrast shows blast wrap mitigated, quenching the fireball in approximately 4 milliseconds, yet the other blast takes over 25 times longer to expand. So this new class of mitigated blast receptacles exceeds all 4 of the defined requirements, in that it handles a very large charge of C4, it stops all primary fragments, it stops all secondary fragmentation in that it stays together, and finally it drastically reduces or eliminates serious human injury near the event. Detailed test reports, photos, and video clips of all of these tests are available from BlastGuard International. This profoundly effective product creates an entirely new class of blast-resistant and blast-mitigated trash receptacles. They are available now from BlastGuard International Incorporated and a nationwide network of representatives for Centerpoint Manufacturing Incorporated. These tests will simulate a large landmine blast and demonstrate the effectiveness of blast wrap in such a threat. As you watch this vehicle rising about 20 feet in the air and completing a 360-degree flip, the size, color, and duration of this fireball indicate an extremely intense blast. Considering the intensity of this blast, the obvious question is, would passengers in this vehicle have survived it? Looking inside the vehicle gives you a very clear and obvious response. They had no chance. Now let's take a look at the same 5-pound blast. The only difference, this time the vehicle is protected with blast wrap. The most obvious and very telling sign of the difference in this blast is the lack of fireball, which speaks directly to the lack of pressure and intensity in this blast. And the same question is appropriate here. Did they survive? In spite of the damage in the front end of the vehicle, the doors open, the glass remains in the vehicle, and even the soft-skin mannequin, upon careful inspection, reveals no secondary fragmentation. These people survived. So let's look again at the substantial contrast in a split-screen review of the unprotected versus blast wrap protected vehicle. From the same camera angle, on the same timeline, in the upper section of the split screen, you see the unprotected vehicle. Fireball is obvious, it's large, and it's a long sustained duration. But indeed in the lower section, the blast wrap protected section, you see no visible fireball. This simply equates low pressure, low intensity of the blast being felt by the occupants of that vehicle, and in fact, the difference could be life or death. The intensity and especially the acceleration and displacement of this event will save lives.
Okay, 5, 4, 3, 2, 1.
That didn't even move it. That thing didn't even move.
Did you think it would?
It didn't move. It wasn't going to move.
Question is, did it fracture?
I'm not sure if during substation.
I don't think it did.
What's the sign? What's the thickness of the steel pad?
On the next one, actually.
And we're going to do blast wrap on the next one now. So this is unprotected oil line pipe that was unprotected that blew that big hole in it.
My name is Kevin Sharp. I'm Senior Vice President of Engineering and Product Development at Blast Guard International.
Okay, now whenever you're ready.
And why are we doing these tests? What would the threats be?
There's a big problem in Iraq with insurgents blowing up oil pipeline, which is halting the production of oil out there, and it's costing the government a lot of money. So what we're doing is we're wrapping the pipeline, which is a piece of 3/8 thick steel used oil pipeline, with blast wrap, a blast mitigation product we've developed, and it will protect the pipe against any charge that's placed in contact with the pipeline. We've just done a shot and punched a hole straight through the side of a filled pipe, and we're going to do a protected one now.
The other one was an unprotected.
Unprotected in contact C4 2-pound charge, and as you'll see, it cuts straight through the side.
And what do you think this will do?
I think the fact that the blast mitigation material is between the charge and the side of the pipe will stop it cutting through, and it should prevent the pipe from being dented or fractured in any way.
Put them both on. 4, 3, 2, 1.
You can look in that monitor and see it, Danny.
It's good, yeah, that works.
You want to go down there? Yeah.
I can already tell there's no water coming out.
Anytime you can put 2 pounds of explosives up against it and just dent it, you did good. Yeah.
What your name is?
James Norman.
Tim. And what do you do for a living?
Blast, I have a wireline service. It's oil field related.
Okay, so you've been in the oil business for how long?
Since '72.
What did you think of what you saw here today?
We had some very good testing. Some very good showings of some quality product that does the job. It withstands a blast.
With the blast wrap product, what did you think of protecting the oil pipelines? What did you see there?
That was what probably impressed me the most, that they could probably insulate with this same stuff, and then they would protect from a blast as well as insulate the pipe. Good.
Anything personal you want to add about blast guard?
Yeah, we've been testing different products over a good 15, at least 15 years, and today was probably one of the best tests I've ever seen.